come to your seat. Okay, this is a recording for Wednesday, April 25th, and this is a continuation of 9.3 geometric sequences and series. And so in these sections, I've been calling on people, but I'm just going to go through some notes so that you kind of have some heads up on how to approach a couple of these problems, and then we'll go on again tomorrow. So this is to write the first four terms. The sequence whose nth term is 2 to the n is geometric, and they're announcing that at this point. And for the sequence, the common ratio of consecutive terms is, and we're going to fill in the blank. So our terms are, oh, just kidding, 2 to the 1, not 1 to the 2. 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4. So they're 2, 4, 4 times 2 is 8. 8 times 2 is 16. And so there's our first four terms. To figure out R, we can take any term and divide it by its preceding term. So R is 4 divided by 2, which is 2, or 8 divided by 4, which is 2, 16 divided by 8. Either way, R is 2 for that one. And then if you want a sequence whose nth term is 4 times 3 to the n, and again, you're being announced that that's geometric, and so it's 4 times 3 to the 1, comma, 4 times 3 to the 2, comma, 4 times 3 to the 3, comma, and 4 times 3 to the 4. And so let's see, I can do at least a few of these. 3 times 4 is 12. 9 times 4 is 36. And then 3 to the third is 27. 27 times 4 is 90, or nope, 108. And then 3 to the fourth is 81. 81 times 4 is 324. And then again, any term divided by its preceding term is that common ratio R. So we can just take 36 divided by 12, which is, excuse me, 3. I was looking at the problem in 3. And notice this, and I'll just kind of slide that up a little bit. You know, it was 2 to the n, so R was 2. It's 3 to the n in that little pattern thing that is is telling us how to do that. And so in the next one, without writing any terms, what is R? What is R? Negative 1/3, correct? And, you know, if we want to validate that, and by the way, if this is negative when n is positive, or excuse me, when n is even, our number in our pattern will be positive, and if n is odd, it'll be negative. So I have negative 1/3 to the 1, negative 1/3 to the 2, negative 1/3 to the 3, negative 1/3 to the 4. And so negative 1/3 to the 1 is, it's an odd power, so negative 1/3. Negative 1/3 times negative 1/3 is positive 1/9. Then positive 1/9 times negative 1/3 again, because we're just really repetitively multiplying by negative 1/3 is negative 1/27. And then timesing by negative 1/3 again gives us positive 1 over 81 as we go through. And then, you know, really, if you just saw that pattern and needed to figure out what R is, it's like 1/9 over negative 1/3, and that's 1/9 when we invert and multiply times negative 3 over 1, so negative 3 over 9. And negative 1/3. Just in case we weren't given, like, you know, a rule to go by, if we had to figure that out, that's the way that we can figure out what R is. And so that should be pretty straightforward to you. I guess looking at that second one gives us kind of the best idea of how to get this pattern that we're talking about. And so if we know the first term, like 12, for instance, in part B. And we know, that our common ratio is 3, then we continue multiplying. 12 times 3 is 36. 36 times 3 is 108, and we're repetitively multiplying by 3. So we get a sub 1 times r to the, and think about what power that has to be. I'm not really multiplying by 3 for that first one, and so that would be 1 less power of 3 as we go through. Oops. And I think I may. Okay, somehow I have to orient the board right now. So I apologize, but there's everything. So I don't know, I guess on the recording you just get to watch me, well, as do the people in the room. You just get to watch me do that. Isn't that a pleasant little, like, sound? Okay, so I don't know if you could tell that, but I was having trouble turning the page, which I still am. So here's the next. Let me just make sure I'm to the bottom there. There we go. And here's the next thing. So this is to find the nth term of a geometric sequence. And so a sub n is a sub 1 times r to the n minus 1. And you can write that and have that in your notes as you're going through this. And then there is that thing at the bottom that I want you to see, but I'll give you a moment to write that. And so keep in mind, that this is a sub 1, a sub 1r, a sub 1r squared, a sub 1r to the third, and so on.
Hello, people of the recording. This is Nicole.
Well, after that greeting from Nicole, you are probably super enthusiastic to move on. So a sub n is a sub 1 times r to the n minus 1. And that's when we start with a sub 1. R is the common ratio. And then this is the other thing, and you do have to be aware of that. So I have a little star there to remind me that. So when you know the nth term of a geometric sequence, you can find the n plus first. Just a minute. Let me say that one more time. You can find the n plus 1th there term by multiplying by r. That is a sub n plus 1 is equal to a sub n times r. And so that is something you just want to be aware of, so that if you need to use that, you certainly can do that. Does anybody in the room need to see this anymore, or you're good to go? Okay. Okay. And this next problem not only asks us to find these terms, but it also asks us to graph, and that's a point plotting exercise for us in these. So here's example 2, right? The first 5 terms of the geometric sequence whose first term, so this is number 2, a sub 1 is 3, common ratio r is 2, and then graph the terms on a set of coordinate axes. So keep in mind that you do know in any situation, you know what x is, right? It's that hidden domain that starts out 1, 2, 3, 4, 5, kind of tells you the number of terms. Because sometimes we kind of forget that hidden domain is there for us as we go. And so a sub n is equal to a sub 1 times r to the n minus 1. Just, kind of seeing that in a different format, not starting with the actual rule. So a sub 1 is 3. A sub 2 is 3 times 2, which is 6. A sub 3 is 3 times 2 to the n minus 1. So we're at n equals 3. 3 minus 1 is 2. And so 4 times 3 is 12. A sub 4 is 3 times 2 to the 4 minus 1, which is 2 to the third. And let's see, that's 8 times 3, or 24. Yes, we absolutely, yes. But I just am going through that process, sometimes that's just what I like to do. 3 times 2 to the fourth is 48. Yes. And so there we go for that. Then we'll plot these 5 points on this coordinate axis. And now I am going to go by ones on my x-axis. Do you agree that would be appropriate? Is it appropriate to try to graph those 5 points on this axis and go by ones for the y-axis? Do you think that's a good idea? Is it? How am I getting to 48? I don't. Okay. But if I am required to show all 5 of those points, then I... So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. If I go by 4s, that would give me 40. Wow, that would be hard. Hard for me. Well, I feel like if I just go by 5s, I'll be at 50 and I'm at 48, right? Oh, but watch. 30, 40, 50. There, 10, 20, 30, 40, 50. So you decide what you want to do, but wait, make sure you do equal increments on that y-axis, because if you don't, well, if you didn't do equal increments, you would not have the kind of shape of graph that we want to see. And so at 1, I'm at 3, so there's 5, so I'm right there. Let's see how well I do. At 2, I'm at 6. Oh yeah, and by the way, the wall is shaking, so that's always super exciting for me. At 3, I'm at 12, so that's going to be, oops, there. At 4, I'm at 24, right there. And at 5, I am at 48, which is right there. Now, again, is this a continuous situation? No, it is not continuous. Because if it was continuous, there would be a curve. And we just have this set 3, 6, 12, 24, and 48. So we just have those points kind of going along in a line as we go. And I have one more that I want to get through today, so let me kind of go. Find the 15th term of the geometric sequence whose first term is 20 and common ratio is 1.05. So that's a unique looking common ratio. So a sub 1, this is number 3. A sub 1 is 20. R is 1.05. And we want to find the 15th term. And we are doing the 1, 2, 3, so it is when that means that n will be 15 as we go through that. And so we know that a sub n is a sub 1 times r to the n minus 1. So a sub 15 is what? A sub 1, which is 20, times r, 1.05 raised to the, which is 14. And now be super careful, because I know mathematically you know this, but does everybody agree you'd be wrong if you went 20 times 1.05 and then raised it? So 1.05 raised to the 14th and then times 20. Tell me what it is. Approximately, I'm guessing, right? A sub 15. Yes. Yeah, no, that's fine. And so as long as we round to an appropriate place. I guess I did hope that that's okay. We have a couple more to go through for tomorrow. So we will do example number 4 tomorrow, and we will move on in these notes. So have a good rest of your day. And for those of you Wem stuck. Hope it went well.